The Pythagorean Theorem, you should be familiar with this, as we have done this multiple times just using the last chapter, all right? So we're going to talk about the Pythagorean Theorem, and we're going to use it in our formulas here. So it says you've studied the relationship between the sides of a right triangle. The theorem summarizes the relationship. It's named after a Greek mathematician, Pythagoras. And there's actually evidence that it was used long before the theorem was ever written down. There's evidence that it was used in the building, that even Egyptians would have used, Chinese empires would have used long ago. So it's been around forever. The Pythagorean theorem says in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. All right? What does that actually mean? It's what you are familiar with. A squared plus B squared equals C squared. All right? This is the formula. Hopefully you know because you've had to use it. What is important here is that A and B are the legs of the right triangle. So it actually does not matter which is A and which is B. All right? Order does not matter there because it is addition. What does matter is that the hypotenuse is C, the longest side or the side opposite the right triangle. That must always be C by itself on one side of the equal sign. Okay? How does this work? There's a couple different ways they show this to prove it. One of the most common ways is an ABC triangle. So if this is A side length, in this case 3 units, that squared is going to be 9 units. If this is 4 units, that squared will be 16 units. And if this side is 5 units, that square will be 25 units. So you can see if you were to square each side, turn each side of the triangle into a square, that adding up these two squares equals this square. That's the most common way it is proved. All right. The other way is by the area. You have these triangles here. And so you have C squared in the center. And then you have this 1/2 A times B 4 times. And you end up getting, if you were to take all of these pieces and pop it into that square, it would fill it up. Doesn't look like it would, but it would. All right. And so you get A plus B times A plus B is basically what you get there. All right. So when you're doing Pythagorean theorem, your A and your B are the ones that are your legs. Your C is your hypotenuse. If you have a variable in there, you're going to have to solve for the variable. You may have to FOIL like this guy, get a trinomial, factor, obviously that's big factoring, set each factor equal to 0, and then see if they work. All right, if one of them doesn't work, like it's a negative that's going to cause a negative when you plug it back in, you can automatically get rid of it, all right? But you should know the basics of factoring. Factors of the last guy that give you the middle guy. All right, so I'm not going to give you something quite this large, but you should know the basics. More importantly, you should know A squared plus B squared equals C squared. Even if it's a smaller example with just numbers, you should be able to figure that out. All right, so the ones I'm going to have you do are just numbers. A squared plus B squared equals C squared. You do need a calculator because I want you to round to the nearest 1 decimal place. 1 decimal place. Go ahead and try these two rounded to 1 decimal place. 1 decimal place. All right, this is find the area of the equilateral triangle JKL. Very, very important that they tell us this word right here, equilateral. By telling us that, we automatically know that all three of these sides are 8 centimeters. The other thing that we actually know here is that if we were to draw the altitude here from that vertex down, it would bisect the vertex and it would bisect the side length, okay? So in an equilateral triangle, this guy right here is going to be bisected, so that's going to be 4. How does that help us? Well, if they want us to find the area, what is our formula for area? Well, our formula is 1/2 base times height. The base we know, it's an equilateral triangle, it is 8, all right? So we know the base part, 1/2, 8. What we do not know is the height. However, we can calculate the height because we have created a perfect little right triangle there. And we know the base of that triangle is 4. We know the hypotenuse of that triangle is 8. And the height of the triangle is going to be the height of my equilateral triangle, okay? And so it's going to help me by allowing me to use this right here to calculate my height. So I'm going to use the Pythagorean theorem to calculate my height. So for Pythagorean theorem, I'm going to use the 4. That's my a squared. My b squared is the height that I don't know. And my c squared is going to be that 8. So when we calculate this, we have 16 here. We have plus b squared. We have 64 here. What's my next step to solve for b squared? Yeah, I need to subtract 16 from both sides. B squared equals 48. 48 does not have a perfect root. So if they want you to round it, in this case, they just did it as a square root. If you're doing an exact calculation, you can just say it equals the square root of 48 and you can put that into your calculator. That way you're not rounding, okay, as you go. So you can actually just say times the square root of 48 if you're using a calculator. And you're going to get approximately 27.7. Because it's centimeters and we're talking about area, it is square centimeters, okay? So base we already knew. Height we used Pythagorean theorem to calculate. All right, we used Pythagorean theorem to calculate. Question. The converse of the Pythagorean theorem says if the sum of the squares of the lengths of the sides of two sides of a triangle equal the square of the length of the third side, then the triangle is a right triangle. Meaning if you give me 3 numbers, I should be able to tell if I have a right triangle based on the 3 numbers. All right, so if you look at this example, determine whether a triangle is right, acute, or obtuse. Well, it's very simple to know if it is right. So we're going to take our 2 smaller and see if it adds up to our larger. All right, our 2 smaller sides are our 7 and 12. We're going to assume those are bases. And then our largest is 13. We are going to assume that's a hypotenuse if this is a right triangle. So 7 squared plus 12 squared. And what is that compared to 13 squared? Is it equal, greater than, or less than? That's what we're looking for. Okay, so when we do this, we get 49, we get 144, we get 169. There we go. All right. When we get those, we have a problem, right? Because these add up to what? 193, right? And this guy is 169. That is not equal, all right? That is not equal, which means that these 2 sides are actually bigger than this. So that means the c squared is smaller. That was my c squared. Than the a squared plus the b squared. All right, my c squared is smaller. So if you look at the options here. All right. Right here, these two add up to approximately 13.9. That's the square root of 193. All right. If it's less than 90, this is going to be less than the 13.9. It's going to cause this side to be shorter. If this were bigger than 90, it would cause this side to be longer than the right angle. So a right angle side is exactly the square root of 193, or 13.9. All right, that would be a perfect right triangle. We know he is not, okay? If this side is smaller than that 13.9, which ours is, okay, that's exactly 13. That means this angle has to go in some to make this smaller. So this is not a 90-degree angle, which means this is an acute triangle, all right? Had my c-squared been bigger than the 13.9, then that means that this angle would have had to stretch out bigger than 90. So that would be an obtuse triangle. So you're always comparing your c. If your c-squared equals these two sides squared, it's a right triangle, easy. If your c-squared is smaller, it is an acute triangle. If your c-squared is larger, it is an obtuse triangle. An obtuse triangle. And that's what this theorem at the bottom tells us. A triangle with side lengths A, B, and C. A is less than B, B is less than C. So you have 3 different side lengths, and you have 2 smaller than the third. If your longest side squared is smaller than the other two, the sum of the squares, you have an acute triangle. If your longest side squared is bigger than the sum of the other two sides squared, you have an obtuse triangle. So given 3 sides, you can tell if you have an acute, a right, or an obtuse. Acute, a right, or an obtuse.